Welcome. I'm so glad you have decided to join me on this journey through mental mathematics over the next 6 weeks. My name is Harmony Venberg Richmond, and I look forward to hearing any comments that you might have towards what you've been learning. So far, what you have accomplished is you have signed a letter of consent with Christy Leverson explaining the project. You also taken a pre-test, a 3-minute pre-test with about 20 questions. um, Again, that will not impact your grade in Foundations in Math 1 or Foundations in Math 2. You've also completed a brief survey on your past mathematics experience, as well as any experience you might have with mental mathematics, as well as some information about yourself. A side note, all of your information will be kept completely confidential and will not be shared with anybody. If you've got any questions or concerns, please do not hesitate to email me, listed below there. What we're going to accomplish this week is we're going to square any number ending in 5, multiply any 1 or 2-digit number by 101, multiply any 2-digit number whose difference is 2, and multiply any 1 or 2-digit number by 99. Now, even though this does look like a lot, I assure you that once you learn these techniques, it will go by super quickly and you will really enjoy doing multiplication with these tricks. So first, starting off with squaring any number ending in 5, there's a few things that we're going to do. First, we're going to multiply the tens digit by the next whole number and simply affix the number 25 to the end. For example, let's look at 15 squared, or 15 times 15. We're first going to take the 1 in the front of 15 and multiply it by its next number in line, which is 2, and we know 1 times 2 is 2. Then we're going to affix 25 to the end of 2. So we're going to have a 2 from our original step 1 and then just putting 25. So 15 times 15 is 225. Let's look at 65 squared. Step 1. Again, we're going to take 6 times the next number in line, which is 7. We know 6 times 7 is 42. We're then going to take 25 and just tack it on to the end. So 42 plus the 25 on the end gives us 4,225. Now looking at this next example, we see we have a decimal and a 0. We can still think of this as 75 times 75 or 75 squared, but first we need to ignore the decimal point and the 0 and then think 75 times 75, which is the same we know as 75 squared. So our original first step 1 now becomes step 2, and we're going to take 7 times 8, which is 56. Again, taking the first number, multiplying it by the next thing in line, giving us 56. Step 3, affix 25 to the end, so 56, 25. And if we think for a moment, we need to apply the test of reasonableness. Now, if we round 7.5 to 7 and 750 to 700, granted that is going against our rounding rules, but just to make the multiplication easier, if we take 7 times 700, something easy to multiply in our head, we know that's 4,900. So the answer of 5,625 is reasonable to what the problem is asking. So we don't need to move any decimals or add any zeros to the end. Next, we're going to learn how to multiply any 1 or 2-digit number by 101. If we're going to multiply a 1-digit number by 101, all we do is take the number being multiplied and write it down twice. Done. If we're multiplying a 2-digit number by 101, all we need to do is take that number and write it twice. And we're done. For example, we have 27 times 101. We're going to write 27 twice. 27, 27, so 2,727. Done. As simple as that. Let's try 56 times 100, or 1.01. Now, although that does look like 101, like before, let's ignore the decimal and think to ourselves 56 times 101. If we write down 56 twice, just like in the previous example, we would have 5,656. Then we need to apply the test of reasonableness. A quick estimate of 56 times 1 gives us 56, which means we'll need to insert our decimal somewhere to give an appropriate answer. So what we'll need to do is insert our decimal in between the two 56s, so 56.56, and we have our answer. Let's multiply two numbers whose difference is 2. Our first step is to square the number that's in between the two, and then subtract 1. Apply the test of reasonableness if needed. So let's take 11 times 13. We know that to get from 11 to 13 is 2, so we can apply this rule. So the first step is to square the number in between 11 and 13, which is 12. 12 times 12 is 144. Step 2, we need to subtract 1 from the number we just squared. So 144 minus 1 equals 143. Apply the test of reasonableness. Since there were no decimals or zeros, we can assume that 143 is the correct answer. Let's look at 1.9 times 210. If we ignore the decimal and the 0, we see it's 19 times 21, which does have a difference of 2. Let's first ignore the decimal point and 0, thinking to ourselves 19 times 21. Step 2, we're going to square the number between 19 and 21, which is 20. So 20 times 20 is 400. Then we'll subtract the 1 from the number we just squared. So 400 minus 1 is 399. And apply the test of reasonableness. If we were to take 2 times 200, we would get 400. So our answer of 399 is reasonable. To multiply any 1 or 2-digit number by 99, our first step is to subtract 1 from the first number, which is the number that's being multiplied by some form of 99. Step 2 is to subtract the first number from 100 and combine to squeeze the two together. For example, we have 7 times 99. Our first step is to subtract 1 from 7, so 7 minus 1 is 6. Then we will subtract 7 from 100, so 100 minus 7 is 93. The third step is to combine the two together, so squish them together, so 693. Applying the test of reasonableness, let's round 99 to 100, and we know 100 times 7 is 700, so our answer of 693 is reasonable. Let's think of 2.8 times 9.9. Again, this rule works when we multiply by decimals, so let's ignore the decimals for now and think 28 times 99. So we're going to subtract 1 from 28, so 28 minus 1 is 27. Then we'll take 28 from 100, so 100 minus 28 is 72. We'll squash and combine the two together, 2,772. Now we need to apply the test of reasonableness. If we think 3 times 10, rounding, is 30, our answer needs to be about 30. And 2,772 is way bigger than 30, so we need to place our decimal so that our final answer looks like 27.72. Well, what comes next? We'll go back to the link on our Wikispaces site to practice a few problems using the 4 techniques we just learned. You will get instant feedback from the location where you'll be practicing. Please avoid using your calculator. Email me any comments, questions that you might have on how things are going, if you have any technical issues as well. And good luck, and we'll see another presentation next week. Thank you.